Hey everyone, so today I'll be going through the intro to complex numbers. So this is what we're going to be going through today. And so firstly, what is a complex number, right? So a complex number is usually made out of a real part and an imaginary part. So what is a real number and what is an imaginary number, right? So real numbers are basically anything that exists on the number line. For example, you have 3, 6. Roots are also real numbers, and pi, e, all of this classifies as real numbers. And imaginary numbers are what doesn't exist on a number line, and the most basic one is I, which is basically root of -1, and you can't find this on a number line. And anything with an I is also a complex number. So for example, 3i, 6i, root 2i, root 5i, all of this classifies as imaginary. So next I will go through how to solve a quadratic equation with complex roots. So, for example, if you have an equation that looks like this, obviously if you try to factorize it, you can't. So, you'll use the quadratic formula, which is, and so you plug the numbers in. And you'll get this. And you can also convert this to imagine in terms of I. So yeah, and that will be our solution. And since so this equation doesn't have any real solutions, it probably looks something like this, where the equation does not pass through the x-axis. Therefore, there are no real solutions, but there are complex roots, and this will be your solution for that equation. Yeah. Next, I am going to go over real part and imaginary part. So a complex number can look like this, and basically what this is you have a real part and you have an imaginary part. And it doesn't have to have both components. For example, 3 itself is a complex number. It's just the i's zeroed. Or 2i is also a complex number, but the real part is a 0. Yep. And how do you find the complex conjugate of this, right? So when we say complex conjugate, we just mean flipping the sign before the imaginary component. For example, the conjugate of 3 plus 2i is 3 minus 2i, and another example is I have I minus 4. Then the complex conjugate will be negative I minus 4 because you're flipping the sign of the imaginary part, which is just I. Yeah. And next we can go to adding, subtracting, and multiplication with complex numbers. So if we take these two equations here, add I minus 4, then basically how you do this is you look at the real parts and you add them together. So 3 minus 4, you get -1. And then you look at the imaginary parts, which is 2i and I, and you add them together, which gives us 3i. So the solution will be -1 plus 3i. And subtraction is mostly the same. So if we take the same equations, so 3 plus 2i minus I minus 4. So again, you take the real parts. Oh, sorry. You take the real parts. So this time is 3 plus 4, so it's 7. And you look at the imaginary parts, which is 2i minus I. That gives 1i. So the solution will be 7 plus I. And yeah, for multiplication, it is basically just expanding the bracket. So let's use this with the same equation. So firstly you take the first components of each bracket and you multiply, so 3i, and then you take this, and so then you get -2. Yep. And then you multiply the outside brackets, which will give you -12. And then lastly, you can do the inner brackets, which will give you -8i. Yeah. And then you can simplify this, and then you'll get the answer of -5i minus 14. Yeah, hope that makes sense. And lastly, we're going to solve problems by equating the real and imaginary parts. So for example, if you have a problem that is 3a plus 2b equals to 6 plus 10i. So 2bi, sorry. So if you have a situation like this, then you can look at the real part again, so which is 3a, and the real part of the right hand side will be 6. So you can equate those two parts. So 3a equals to 6, so you get a equals to 2. Now after that, you can equate the imaginary sides. So you'll get 2bi equals to 10i, so 2b equals to 10. So then you'll end up with b equals to 5. Yeah, and that's it for today, and I hope this makes sense, and I hope it will help you in your revision journey. Thank you.